Hello everyone, welcome to my channel. If you are new to my channel, please subscribe to my YouTube channel, so you can join our tech family. If it is informative to you, please like our video, share it with your friends so they can get help with these video, and don't forget to press all notification bell icon so you get regular update and don't miss any single video.
So let's start with WPA. WPA is kind of like WEP all grown up. Who put on his big boy pants? Well, that was what it's designed to do. It's short for Wi-Fi protected access, and it definitely gave us better protection than what we experienced with WEP. And it was formally adopted back in 2003, which was about a year before WEP was officially retired. So it was designed to patch the issues that we had with WEP. Now, the most common WPA configuration is using WPA PSK. That's short for pre-shared key. And these keys are 256-bit, which is much stronger than the 64-bit and 128-bit keys that we saw with WEP. Now, one of the biggest changes of implementing WPA included a message integrity check. And what we mean by that in non-geek terms is the ability to check to see if an attacker or somebody had captured or altered the packets as it was passing from the access point to the client. And we do that with something called Temporal Key Integrity Protocol, also known as TKIP.
Dale, what's TKIP?
Well, under TKIP, a client starts with a 128-bit temporal key that is then combined with the client's MAC address. Once the TKIP has been created, it wraps itself around WEP, because that's all WPA is fixing WEP. And then unique encryption keys are then created for each wireless frame, which creates a more secure network connection. However, despite the improvement that WPA gives us over WEP, the ghost of Christmas past. No, the ghost of WEP still haunts WPA. Now, the really cool thing about WPA back in the day is that it didn't require you to go off and buy new hardware. It was simply a firmware upgrade on the networking devices. But here's the downside to it. Because it had to recycle certain elements used in WEP, it actually ended up creating exploits. In fact, today, WPA by itself is not considered secure, just like WEP or WEP. So then along came our big brother, WPA2. WPA2 created much stronger protection for us. And one of the reasons for this was the mandatory use of AES algorithms and something called CCMP, or Counter Cipher Mode and Blockchain Message Authentication Code Protocol. Yeah, nothing in your immediate future on that one. It was just a new algorithm that replaced TKIP. Now, WPA comes in two different flavors. The first one is referred to as WPA Personal. It uses a pre-shared key. It does use a 256-bit key for encryption, and that encryption is based off of anywhere from 8 to 63 ASCII characters. You all have probably set up an access point before where you've gone through and you've created a passcode or a passphrase for your wireless network. Well, it's those characters that are used to help create that 256-bit key.
Well, gee, Dale, it sounds like if I'm using WPA2, I'm doing pretty good.
Yeah, guess again. Some of the same vulnerabilities that were the big hole in WPA armor exist with WPA2, and here it is. Any of you guys on your Wi-Fi routers, are you using WPS?
Dale, that's too many acronyms. I can't keep track of all of them.
WPS is that Wi-Fi protected setup. It's that little button. All you gotta do is hit this button and you'll get your device to hook right up. Well, WPS is burnt into the firmware. It doesn't change or rotate, and it's a code. Now, I could still try to break into your WPA2 network by using brute force attacks, and they could take anywhere from several hours to a couple of days, maybe even a week. But if I go after your WPS, this vulnerability can be hacked by some software called Reaver, and I can crack that anywhere from 2 to 14 hours, depending on my system. So if you can, try to disable WPS. The other flavor of WPA2 is referred to as WPA2 Enterprise. Now, WPA2 Enterprise addresses the concerns regarding the distribution and managing of those static passphrases. And it's actually going to control access on a per-account basis by tying into some type of authentication service. Those are typically handled by either EAP or Radius. And this mode requires credentials such as a user's name, a certificate, maybe a one-time password, and the authentication occurs between the station and this centralized authenticating server. The access point, or the wireless controller, simply monitors the connection and directs the authentication packets to the authentication server. Typically, this is going to be a radius box. Now, this is all based off of the enterprise environment using AES with CCNP, which is extremely strong compared to RC4. Now, to show you what this looks like, let's take a look at the workings of 802.1x. This framework supports both user and machine authentication with port-based controls that works for both wired switches and wireless access points. Now, the major components involved in this are the supplicant, which would be the devices we're trying to gain access with, the authenticator, which is typically an access point. But if you're using a centralized access point architecture, it could be on a switch or a controller. And this is in charge of authenticating the client to the network. And the other component is the authentication server. Now, it can't be just any authentication server. It has to be an authentication server that supports EAP. Or I should say it's compatible with EAP. And it has to be the EAP that comes on the supplicants. Now, typically, the authenticator processes the requests from the supplicant and leaves the interface blocked unless it's directed by the authentication server to let it through. And the authentication server receives and processes authentication requests that it gets from the authenticator, the access point, using a somewhat extensive process. So in this case, when the access point receives EAP traffic from the client, it converts it and sends it to the radius server. After the authentication process starts, the client receives what we refer to as a master key, or an MK. Now, the master key is tied to that authentication session. Now, since both the authentication server and the supplicant has the master key, they both generate what we refer to as a primary master key, or a PMK. Now, the access point receives a PMK from the authentication server through some radius attributes that you would assign. Once the client and the access point have the PMK, the client and the access point generate something known as a pairwise transient key. And the reason why they both generate it is because we don't want to exchange it across the Wi-Fi, which eliminates a man-in-the-middle attack. Now, because the process of a client authenticating to a radius server can take hundreds of milliseconds, not seconds, milliseconds, but believe it or not, it's long enough that a device like a phone or a laptop, it's unacceptable. So most enterprise wireless products that have 802.11i features have things built into them like PMK caching as well as pre-authentication. So you can see that there's a lot of keys involved with this interaction. So much so that you may have to involve Vince Corthrow, Keymaster of Gozer. Anybody? Anybody? Okay, homework assignment. Go watch Ghostbusters.
We hope you enjoyed the video and found value in the content. We value your feedback. If you have any questions or suggestions, feel free to post them in the comments section or contact us directly via our social platforms. Thanks for watching.